Hi friends, VQ has released two model question papers on the subject Automata Theory and Computability with the subject code 18CS54, and many of my viewers had requested me to solve these two model question papers. So in this video, you will get the solutions for module 1 questions of both the papers. Before I start, a message to my viewers. I thank you all for your amazing response to my channel. The very objective of this channel is to share ATC subject knowledge and help build a strong and effective conceptual understanding among the target audience. Thank you for all the feedback and motivation. I commit to make these lectures as effective as possible. I would like to thank all my viewers who have subscribed my channel. But maximum watch hours of my channels are viewed by my viewers who have not yet subscribed. So if you find my videos useful, subscribe my channel so that this knowledge reaches wider audience and they can also benefit from the same. Join me in this learning journey by just a small click on the subscription button. Let's learn together. So with this note, let us start with the first. So the first question is to define the following with examples: alphabet, power of an alphabet, concatenation, language, string. So all these definitions with examples are already explained in my video lecture of module 1, lecture 1, consisting of definitions with examples. So you can watch this video. Next question is to define a DFSM and draw a DFSM to accept the given languages. So language B, C, D and E I have already solved in my video lecture of module 1, lecture 3, session 1, designing deterministic finite state machine. This is the link, so you can watch. The one which is not solved in my video lecture is decimal strings which are divisible by 3. So let us solve it now. For a number to be divisible by 3, the remainder must be equal to 0. If not, the remainder will be equal to 1 or 2. So here we go for representing the remainders as the states. Remainder is equal to 0, labeled as Q0. Remainder is equal to 1, labeled as Q1. And remainder is equal to 2, represented as Q2. Now, in between 0 to 9, all the numbers which are divisible by 3 are 0, 3, 6, 9. On division, their remainders are 0. Hence, the initial state is the final state. Next, numbers 1, 4 and 7, after division by 3, the remainder for these numbers 1, 4, 7 is 1. So we have a transition 1, 4, 7 from Q0 to Q1. Next, for 2, 5, 8, after division by 3, remainder is equals to 2. So we have a transition from Q0 to Q2, transitions 2, 5, 8. Similarly, go for the next state. Q1. Assume At Q1 already I have got a 1. After 1, if I have a 0, that is 10. Remainder will be equal to 1. So we'll be having a self loop for 0, 3, 6, 9. Next, if I have a 1 already followed by a 1, then after division by 3, remainder is equals to 2. So for 1, 4 and 7, it will go from Q1 to remainder to state. Last, followed by 1, we have 2 or 5 or 8. Then all the three numbers are divisible by 3. So we have a transition 2, 4, 5 from Q1 to remainder 0 state. Similarly, we have to find out for remainder 2. Already we have assumed from Q0 we have a 2 and a 2 followed by a 0 or a 2 followed by a 3. Then remainder will be equal to 2. So we have a self loop for 0, 3, 6 and 9. Next, after 2, if we have 1 or 4 or 7, then all these three numbers are divisible by 3. So we have a transition 1, 4, 7 going to remainder 0 state, which is also a final state. And at last, one more transition followed by 2 if we have 2 or 5 or 8, then remainder is equals to 1. So we have a transition from 2 for 2, 5, 8 going to state 1 as remainder 1. So this is the complete DFSM for a decimal string which is divisible by 3. The final definition of the DFSM is M is equals to K summation delta SA, where K consists of 3 states Q0, Q1 and Q2. Summation is 0 to 9. Initial state is Q0 and final state is also Q0. Transition diagram and transition table. So either you can write the transition table or you can write the transition functions. So here I have written the transition functions. Delta of Q0, 0369 goes to Q0 self loop. Q0 147 goes to Q1. Q0 258 goes to state Q2. Similarly for Q1 and Q2. And finally, for a given string, we have to find out whether it is acceptable by this DFSM or not. Input string is 24. 24 is divisible by 3. Then initially at state Q0 for input string 24. Q0 2 goes to Q0 2 goes to state Q2 for input 2. Next Q2 4 derives Q2 for 4 goes to state Q0. So from Q2 it goes to state Q0, input is consumed, and the state Q0 is an accepting state or final state. Hence M accepts the string 24. So this is the complete definition of a given DFSM. So whenever a question asks to design a DFSM, you are not supposed to just write the transition diagram and leave. You have to complete the definition also. And if a string is given to check whether it belongs to that particular language, then go for deriving for that particular language. Else, that particular string. Else, take your own string and derive the instantaneous descriptions and check whether that string is accepted or not. If it reaches the final state after consuming the input, then the string is accepted. Else, after consuming the input, if is still in the intermediate state like Q1 or Q2, then the string is rejected. So this is how we are supposed to write the complete definition of the given DFSM.